Hello everyone, welcome back to Deeksha Karnataka YouTube channel, and in the COMEDK series today I am going to discuss dual nature of radiation and matter. It is also a very important chapter for COMEDK. So let's start with the questions. Light of two different frequencies whose photons have energies 1 electron volt and 2.5 electron volt respectively successively illuminate a metallic surface whose work function is 0.5 electron volt. Ratio of maximum speeds of emitted electrons will be. So first of all, we know that kinetic energy of the emitted electrons is basically the energy of the photon. Okay, that is first case EK1 is basically 1 eV minus the work function, which is 0.5, so that is 0.5. okay, and EK2 is 2.5 minus 0.5, that is 2, right? This is the formula, easy. Now what is kinetic energy? EK1, kinetic energy basically half m v1 square. As easy as that. The questions are not difficult as many students think. Okay, now what you have to do, you have to divide them. So you get v1 square by v2 square equals to what is the value? 0.5 divided by 2. Okay, so it will be 1 upon 4, or v1 by v2 will be 1 upon 2. So v1 is to v2 will be 1 is to 2. So the correct answer is option D. Next question. The photoelectric threshold wavelength for silver is lambda naught. The energy of the electron ejected from the surface of the silver by an incident wavelength lambda, where lambda is less than lambda naught, will be. So what is the energy? We already know that energy is basically h nu minus h nu naught. H nu is the energy of the incident photon, h nu is the energy of incident photon, and h nu naught is the threshold work function or threshold energy. Okay, so from there we can write hc by lambda minus hc by lambda naught, where lambda naught is the threshold wavelength. Now if you take hc common, you get this as 1 upon lambda minus 1 upon lambda naught, or you can write this as hc into lambda naught minus lambda divided by lambda naught. Okay, just LCM and do the multiplication and you will get this, right? So correct answer is hc lambda naught minus lambda by lambda naught. Next question. According to de Broglie hypothesis, the wavelength associated with moving electron of mass m is lambda e. Using mass energy relation and Planck's quantum theory, the wavelength associated with photon is lambda p. The energy of electron and photon is same, then the relationship between lambda e and lambda p. So first of all, we know that energy of a photon is basically h into nu, right? So from there we can write this as h c by lambda photon, right? So energy of from the energy relationship we can find whatever is the value of energy, right? Now the same energy, if you give it to electron, then what is the momentum of the electron? Momentum of the electron is 2m into E, right? This is the energy of the electron. Now what is the wavelength of the electron? Wavelength of the electron is h by p, that is h by square root of 2m into E, or h by 2m into hc by lambda p, or you can write this as proportional to square root of lambda p. So this is in division, so this will go up. Okay, division of division, so it will be multiplication. So lambda electron is basically proportional to lambda p, or lambda p, that is lambda photon, is proportional to lambda electron square. Okay, so lambda p is proportional to lambda electron square. Next question. the potential energy of particle of mass m varies as ux is E naught for 0 less than equals to x less than equals to 1 and 0 for x greater than 1. Okay, the de Broglie wavelength of the particle in the range 0 less than x less than lambda 1 and then range x greater than 1 is lambda 2. Sorry, there should be 1 here. Okay, for 0 to 1 it is lambda 1 and for greater than x equals to 1 is lambda 2. If the total energy of the particle is 2 E naught, then find lambda 1 by lambda 2. So first of all, total energy of the particle is 2 E naught. Okay, so what is the kinetic energy for this range? Kinetic energy for this range, very easy question. Kinetic energy for the beginning stage, okay, for this condition 0 less than x less than 1. Okay, so for this range kinetic energy will be total energy minus potential energy, that is E naught. Okay, so what is the wavelength lambda 1? Wavelength lambda 1 is h by square root of 2m E naught, right? Now for the range x greater than 1, potential energy is 0, so kinetic energy equals to the total energy, that is 2 E naught. So what is the wavelength lambda 2? Wavelength lambda 2 is h by square root of 2m into 2 E naught. Okay, now they asked you what is the find the ratio of lambda 1 by lambda 2. So lambda 1 by lambda 2 will be square root of 2. Okay, this one is division of division, it will go up. So correct answer is option A. Okay, next question. The work function of cesium is 2.27 electron volt. The cutoff voltage which stops the emission of electrons from cesium cathode irradiated with the light of 600 nanometer wavelength is. So you have to find the cutoff voltage or the stopping potential. First of all, you have to convert this energy into electron volt, then you can calculate the stopping potential. Okay, so 600 nanometer, how to convert 600 nanometer into EV? So it will be hc by lambda. Okay, that is the energy, and hc is 1240 divided by 600. Okay, this is the energy, right? So you can cancel that, you will get 6 to the not 6 so 6 to the 12, 62 divided by 2, it will be 30, so it will be 15 31, which is very close to 2. Okay, very close to 2, slightly more than 2, 2.1. Okay, 2.1 up to. Now if you see that the work function of cesium is 2.27, so the energy of the incident photon is less than that of the work function. So if the energy of the incident photon is less than that of the work function, no electron will come out of the surface, so no motion will happen. So none of this is the correct answer for this question. Okay, so this is the correct answer for this question. No photoelectric emission happening in this case. Next is light of frequency 10 to the power of 15 Hz falls on a metal surface of work function 2.5 eV. The stopping potential of the photoelectrons in volts is. So this is a slightly tricky question. First of all, energy is given by h into nu, but here the it is not given in terms of wavelength, it is given in terms of frequency, so you have to convert it into EV. How to do that? H is 6.62 into 10 to the power of minus 34 and the frequency is 10 to the power of 15 divided by the charge of an electron, that is 1.6 into 10 to the power of minus 19. Right, so what is the value? 19 plus 15 is 34, so 34 will cancel, so you will get 6.62 by 1.6, so it will be approximately 4 eV. Okay, we will find the closest value, then we will see whichever is the closest one. Okay, so approximately 4 eV is the energy 4 16 is 64, right? So that is why it is 4 eV. Now the work function is given 2.25 eV, so the stopping potential is 4 minus 2.25, 4 minus 2.5, that is 1.5. okay, so the answer is 1.5 eV. Now if you see the answers, only one is correct, that is 1.6. okay, this is the closest. Always closest is the greatest. A proton accelerated through a potential V has de Broglie wavelength lambda. Then the de Broglie wavelength of an alpha particle when accelerated through the same potential V is. So what is the, when you accelerate a electron in the potential or proton accelerates through a what should I say, in the potential V, the energy is basically given by E into V, right? This is the kinetic energy of the proton. Now in case of, this is for proton, for alpha particle it is 2E into V because it is doubly charged, so the energy of the alpha particle will be 2eV, right? Now lambda is equals to H by P, that is H by square root of 2me. okay, so this is for proton. For alpha particle, H by, now if you see, if this is proton, so we can say this is basically 2EP, right? So here if I write this as EP, the energy of the alpha particle in the same potential will be twice, right? And mass of alpha particle is 4 times that of the mass of a proton, right? So it will be 4m, because alpha particle has 2 protons and 2 neutrons, basically helium, right? And the energy is twice that of EP, so we can write this as H by 2 MEP, and here we will have 2 root 2. okay, so it will be if you see, this is the wavelength of a proton, that is lambda divided by 2 root 2. So the correct answer is option C. Next question, a particle of mass 1 mg has same wavelength as an electron moving with the velocity of 3 into 10 to the power of 6 meter per second. The velocity of the particle is, mass of the electron is given 10 to the power of minus 31 kg. So mass of the particle is 1 mg. 1 mg means 1 into 10 to the power of minus 3 kg, right? Milligram. Now they have the same wavelength, okay, that means H by mv equals to H by m of electron, velocity of electron. Okay, basically they have the same momentum. If they have the same wavelength, that means they have the same momentum. Okay, so mass of the particle is 1 into, so we can write, I am just keeping one line, so maybe you were thinking that how I am writing this. So mv equals to mev, right? They will cancel. So mass is 1 into 10 to the power of minus 3, velocity we don't know. Mass of electron is 9 into 10 to the power of minus 31. Okay, and 9.1 we will consider it later, and velocity of the electron is 3 into 10 to the power of 6. Okay, so velocity is 3 9s are 27 into 10 to the power of, main is 10 to the power, minus 31 plus 6 minus 25, and there is 1 minus 3 over here, that will go to other side, it will become minus 22. Okay, so 27 into 10 to the power of minus 22, or you can write this as 2.7 into 10 to the power of minus 21. So if you check the answer, this is the correct answer. Okay, next, which of the following is incorrect about a photon? Its rest mass is 0. Yes, its rest mass is 0. its energy is h nu. Yes, its energy is h nu. Its momentum is h nu by c. Its momentum is h nu by c. It does not exert pressure. It do exert pressure. So this is not a correct statement. We call it a radiation pressure. Okay, and in fact we try to find the pressure in, I think I have solved one question in the past where we tried to calculate the pressure exerted by a photon. So that is also there. The mass of two particles having same kinetic energies are in the ratio 2:1. Then their de Broglie wavelengths are in the ratio. So H wavelength is equals to H by square root of me, right? 2me. This is the momentum, right? This is the formula for momentum. How I am writing this? If you have missed this video, I have done the theory part of this in the KSET Master Stroke series. You can check that out. Okay, even though it is what about KSET, the syllabus is same, so videos are same. Questions are slightly different. Other than that, syllabus for KSET and COMEDK are same. So H by square root of 2me. This is the wavelength lambda. Now what we have to do, we have to find the so lambda 1 by lambda 2. So you can see that lambda is proportional to 1 by square root of mass, right? So lambda 1 by lambda 2 must be equals to square root of mass 2 divided by square root of mass 1, inversely proportional. So they should be like this, right? Now what is the ratio given? m2 by m1. Now if you observe that the mass are given in the ratio is 2:1. So 2:1 is the mass, right? Energy is given same here. So this is m1, this is m2. So m2 by m1 will be 1/2. m2 is 1, m1 is 2. So 1/2. So ratio of their wavelength will be 1:√2. 1:√2. Next question, the photoelectric work function for a metallic surface is 4.125 electron volt. The cutoff wavelength for a photoelectric phenomena for the surface is. So photoelectric work function for a metallic surface is given by, so phi is given by 4.125. Okay, the cutoff wavelength for the photoelectric phenomena for the surface. So we are trying to find what is the cutoff wavelength, that is Hc by lambda naught. Okay, we have to find this value. Now how to do that? We know that Hc is 1240 by lambda naught in terms, when we are trying to find this in terms of nanometer. Okay, so nanometer we have to convert it into angstrom, but nanometer is much easier than converting everything into meter. Okay, so lambda naught equals to 1240 divided by 4.125, which is almost equals to 3 4s are 12, 310 nanometer, almost. Okay, if you take this as 4, you will get this as 310. So lambda naught equals to 3100 angstrom. Okay, angstrom means only multiply by 10. Okay, so correct answer is option D, 3000 angstrom. So next question, the energy of the photon of wavelength lambda is. So energy of photon of wavelength lambda, energy is h nu, that is hc by lambda. Nu is c by lambda, so correct answer is hc by lambda. Next, the momentum of electrons having a wavelength 2 angstrom given h is equal to 6.626 into 10 to the power minus 34 joule second, mass is 9.8 kg. So you have to convert the wavelength into momentum. So wavelength equals to h by P, so P equals to h by lambda. Okay, as simple as that. So what is the h? H is 6.626 10 to the power of minus 34. You don't need the mass of the electron because it is directly momentum. We are calculating momentum, so mass is not required. So wavelength is 2 angstrom. 2 angstrom means 2 into 10 to the power of minus 10. Okay, so it will be 3.313, okay, into 10 to the power of minus 24. 3.313 into 10 to the power of minus 24 is the answer. Next, the photoelectric current of voltage in a certain experiment is 1.5 volt. What is the maximum kinetic energy of photoelectrons emitted? Stopping potential. Okay, so stopping potential is given and you have to find the kinetic energy, right? So maximum kinetic energy. Kinetic energy itself is the EV naught. Okay, stopping potential. E is 1.6 into 10 to the power of minus 19 and potential is 1.5. so it will be what will be the value? So basically if you multiply them, 16 into 15, it will be 240, that is 2.4. so 2.4 is, if you multiply them, and 10 to the power of minus 19. So 2.4 into 10 to the power of minus 19 joules. Kinetic energy cannot be negative. Remember that kinetic energy cannot be negative. Kinetic energy is always positive. Now, last question. Which one of the following is not associated with photoelectric effect? Photoelectric effect is instantaneous. Yes. Photoelectric current depends on the frequency of incident light. No. Photoelectric current does not depend on frequency. It depends on the intensity of the incident light. So this is not associated with photoelectric effect. Okay, velocity of photoelectrons depends upon the frequency. Yes, below the threshold frequency emission of photoelectrons is not possible. So this is also not correct. Okay, I think it is below the threshold frequency emission of photoelectrons is not possible. Okay, anyway, there are some maybe typing error. Photoelectric current does not depend on frequency, it depends only on the intensity of incident light. Okay, it is independent of the frequency as long as the frequency is higher than the threshold frequency. If it is lower than threshold frequency, yes, definitely it will there will be no emission. If it is higher than the threshold frequency, then current does not depend on frequency. Okay, in maximum kinetic energy of the electrons emitted depends. That is the only thing. Other than that, the saturation current, the maximum current in the circuit, or the current in the circuit does not depend on the energy of the photon, that is frequency. Right. With this note, I would like to end this session. I will be back with one more session, atoms and nuclei. Then we have semiconductor electronics as well. So everything will be covered in the Launchpad series. I will be back. Till then, bye.